Okay, so here's our demos. It's fairly late at night. Everybody's asleep. And we're going to try to do this. I'm not sure how good it's going to come out. Let's go through the parts real quick. This is obviously use with light box. This is just our power supply. Okay, I think it's 13 volts or something it goes down to. And then we have here, which is called a light box. If we see inside there, I don't know if you could see that. That's like a lens. On the other side, you might be able to see the bulb. There we go. It's almost like a bulb that you would use in an overhead projector, pretty close to that. You'll see our slits here, single slit, and then 3 slits. I also have one with like 4 and one with a larger one, but I think this is the only one. I didn't realize we only had a single on there too that we need. So basically what happens is it will produce light rays, and we could see how they interact with different things. Okay, maybe we'll see internal reflection, refraction, reflection, and I can't remember honestly at this moment right what it's called, but I think it's additive color. There's subtractive and then additive that deals with like primary colors of light, which are like red, blue, and green. And here's my Legos. We'll talk about what we're going to do with that here in a second. These are pieces of acrylic. This actually goes to a different set. We don't have it at the school, but it must have been given to us by somebody, these big acrylic pieces, where you would attach these to a blackboard, and you would have light rays that hit them, and you could actually see it on up on the board. I have a larger one here, which would be nice. And then what comes with our light box are these smaller pieces of like acrylic. And we also have a simple mirror. I'll try to blind you there. Oh, that's me. That's me right there. Anyway, it's pretty late. Let's preface it again with that. And then we have our blue. And so what you use these for is cyan, orange. We don't need those. We need not magenta, green, and red. So Isaac Newton showed that white light is made up of all the colors, and he did that with a prism. And it's sort of like this. So, but you know, I hope you know what a prism looks like. It's a triangle and it's long, and you shine light on it. And if you look at a wall, you'll see all the colors of the rainbow because it spreads it out, and that's because of refraction. And in the notes, you'll see it talks about how different wavelengths actually are refracted different amounts. Okay, and that's why we see that, because different colors of light have different wavelengths. So okay, so here's what we're going to do first. I was hoping that the boys would still be up and we could do this together, but I had to wait till it was dark out and they're already in the bed. We did this the other day. I think they thought it was kind of cool. So we have blue, green, and red. And so what we're able to do is actually put those in our light box. And so in our light box here, there's mirrors. Oh, that's weird. Okay. It's hard to do this on my kitchen table. It's getting smaller and smaller every day with Matthew's work and mine. And apparently Malachi is going to start getting pre-K work to do at home. But I don't know if you could see that very good. Basically, the light's going to come shining out of here. The red will go straight. Blues on this side, greens on this side. And we'll use these mirrors on the side to direct the light. So if we put all those, all that light together, we should get white light. So I was trying to think about how do we do this. And the way I came up with, I had the boys' hands in front of it. And so when there's red light, it's one color. If there's blue light, it's another color, okay? And then if we put them all together, you get white light, you'll actually see the color of the hand, okay? At least fairly close. Now the light's on in the other room, so this might not be perfect because you'd want it to be perfectly pitch black, okay? So we're gonna do that first, and hopefully we can see that my hand looks fairly the normal color when I combine all these lights together. Secondly, I'm gonna take these Lego blocks. They gave little different color, like they kind of look like this, but they're a different color, solid. And basically what you're trying to show is that only the wavelengths in here are reflected. So for example, if blue light were to hit this, you'd only be able to see blue here. All the other ones should actually be black except white. Okay, white would actually look blue because it'd be reflecting the blue color. If it was red, the blue and the green would be like black or close to it. You wouldn't really be able to see it, especially if it was a perfectly dark room. And you'd be able to see this is blue, and you'd be able to see the blue one. Red is red if you have red light, and this would be red too, because it'd be absorbing, all the other ones would be absorbing the red light. The red one would be reflecting it. Hopefully that makes sense. Okay, so let's see if we get this fired up. I'm going to turn the lights off. There's too much light in the other room, I think. So there we go. Okay. And you can see over here, blue, green, red. Oh, you can almost see it. Look at that already. I don't know if you could see. Anyway. Okay. So first off, we're just going to point red. I don't know if you could see it. It's red. Okay. Now I'm going to have blue come in. It's kind of purplish. Even on the screen, it kind of looks purple. And I'm going to bring my green in. I don't know if you could see that. But right in the middle, right through here, it basically is producing white light because the green, red, and blue light are all coming together. And my hand looks, you know, it's not perfect, but it looks fairly close to the real color of my hand. It's a little extra red. I think we don't get enough of the green saturation and the blue saturation. But anyway, you could definitely tell it produces more of a white light. Okay. I don't know if you could see that from the angle. I'm going to take this down here. Try to do it this way. Okay. You can see Lego pieces over there too. So that's when all the light is hitting it. Let's see if I can sit down. Right there. So I'm going to take away all except for the red. Okay. Now, I don't know if you could tell or can remember, but red was on the bottom. Okay. You're kind of seeing a reflection off the ground there. But this is actually reflecting red, and I could see it. You kind of see it as whitish. The blue's above it. It must have a little bit of red hue in the blue, and then the green's above that, which looks like perfectly black. Now above, I know in the camera it looks white, but to me it actually appears red. I think why? No. We're getting some of that blue. Okay. But the bottom one is actually the red one, and the top one is the white one. Both look the same color. They're both reflecting red light. I don't know, I should do it like this. Okay. Now, I'm going to see if I could close off the red and only show blue. Let me see if I could do that. Okay. And obviously that is not working. So we're going to move it over here. I'm getting too much white light.